This video will show you how to use an Excel worksheet that I made to help you to do the statistical inference for one population very quickly. If you want to do a confidence interval estimate for proportion, for instance, you can click on this confidence tab. And you look at this worksheet, very right-hand side is for proportion. You have a place that you can put in sample size, and you have a place that you can put in the counts for category of interest, and then the confidence level. These are actually pretty much just three places you want to enter your data. So let's look at an example. So for instance, in this exercise problem, in the public opinion poll agency want to find out the estimate the percentage of employed adults who fear losing their job within the next year. So they took a random sample of 100 subjects, and 35 out of 500 selected employee adults will fear losing their job within next year. So it's 30 out of 100, and we want to use this to help us to figure out a 95% confidence interval estimate for estimating the proportion of the population of employed adults who fear losing their job within next year. Okay, so this 100 will be the N, and the 35 will be the number of successes, right? Actually, the number of people, employed adults who fear losing their job within next year. So with these information, you should come to this worksheet, typing 100 here for N, the sample size, 35, these are number of adults who fear losing their job. You want a 95% confidence interval. So if you plug these numbers in there, and you're going to get a marginal error 0.093. Of course, your estimate proportion, that's 35 out of 100, is 0.35, 35%. So your confidence interval estimate proportion will have a point estimate 0.35 and a marginal error 0.093. Okay. Now, if you do it by hand, it'll be like this. Let me bring this screen into the screen. So if you do it by hand using the confidence interval estimate for proportion, you have to calculate the proportion, simple proportion at 35 out of 100. That's 0.35. That's this point estimate for estimating proportion. With a 95%, you calculate the z-score for, and the formula is 1.96. And you multiply the square root of p half times 1 minus p half over 100. This quantity here will be 0.0935. So if you do it by hand, you will get exactly the same answer that you get from this Excel worksheet. You have a p hat, that is this, and marginal error, that is this, right? In fact, in this worksheet, I use this level to help me to use the Excel function to calculate the z-score, and then use it actually to calculate the marginal error. And if you want to present your result in an interval form, then this will be a lower limit, this will be an upper limit for the confidence interval. This will be from 0.35 minus the marginal error, and the 0.4434A will be from simple proportion 0.35 plus the marginal error 0.0934. Okay, and this same worksheet can help you to do hypothesis testing for proportion. Right? There is a z-test. If you click on z-test tab, right, you see the z-test for proportion, and you just put in sample size there, and then number of successes. Right, this is really just a counts for the category of interest that you try to test for proportion, and then you specify the proportion to be tested. This will be the proportion under the null hypothesis, and specify the alpha level for the test. Now, this worksheet actually is designed so that automatically you can have a p-value calculate if you do a two-sided test, and also p-value calculate if you do a left-tailed test, and a p-value for right-tailed test, and also the decision whether you reject or not reject null hypothesis based on the alpha level that you use for the test. Right, so it help you to actually do the z-test for proportion very quickly. As soon as you plug in these right information to the right place, right, you get the one sample test for proportion right away. Okay. Let me show you how to use this Excel worksheet to work on this example. A researcher hypothesized that the percentage of people living in the community who has no insurance coverage during the past 12 months is not 10%. So it says it's not 10%. That would be your alternative hypothesis, right? The proportion not 10%. And you took a random sample of 1,000, and 122 answered that they did not have any health insurance coverage during the past 12 months. You want to test this hypothesis at 5% level of significance. So based on the question, you know that the null hypothesis is the proportion is 10% versus alternative percentage not 10%. So you have to calculate the z-test statistic using the sample data. All right, so p-hat actually is 122 over 1,000. That's 0.122, and you standardize that using this formula, right? P0 is just the proportion on the null hypothesis, 0.1. So you plug those information in there, you get the z-test statistic 2.32. And notice that it's a two-sided test. So the p-value will be area to the right of this statistic. You use the stereo table to find that, right? And since it's two-sided test, you multiply that tail area by 2. So you get the p-value for two-sided tests. Okay. Now, if you use that worksheet, right, you can do this problem very quickly. You have a sample size of 1,000. So plug in there. Number of successes, 122. Okay. So you got a simple proportion of this. You want to test a hypothesis 5% level significant. You want to test whether the proportion is 1%, 10% or not. So it's 0.1. Okay. Once you got all these numbers set up, type in. You get that z-test statistic. Remember, it's 2.32, and this is more precise. That number is test statistic. You want to do a two-sided test. The p-value is what? It's 0.02. That's exactly the answer you saw in this example. So the Excel worksheet can help you to. This Excel worksheet can help you to actually calculate the p-value very quickly, and with that number, you can draw your conclusion right away.